Assalamu alaikum everyone. Today we are going to solve 9709 February March 2025 paper 42 mechanics. Okay, without any wasting any minute, let's move to the first question. Okay, this is the first question that we have. There are three coplanar forces of magnitude 40 newtons, 30 newtons and x newtons act at a point, which is this point, at a point in the direction shown in the diagram, given that the forces are in equilibrium. So that's the key word over here. The forces are in equilibrium, which means that the object is at rest. We need to find out the values of theta and the value of x. So whenever in the question we can see that there are two forces that we are not supposed to resolve, because this is the point of observation, and with respect to the point of observation, 30 Newton force is perpendicular and the 40 Newton force is parallel to that direction, to the plane. And we only have to resolve the x Newton force. So let's resolve the x Newton force. This is going to be the horizontal component and this is going to be the vertical component. So for the horizontal component it will be x cos theta, and for the vertical component it will be x sin theta. Now since the question says that it's in equilibrium, so equilibrium means it is at rest, and at rest it means that the upward forces, sum of the upward forces will be equal to the sum of the downward forces, and the sum of the right side forces will be equal to the sum of the forces on the left side. So the forces which are acting in the upward direction is just one in this case, that is 30, and the forces that is acting downwards is just only one, that is x sin theta, sorry. Similarly, if I talk about the right, there is just one force that is acting in the right direction, which is x cos theta. In the left direction there is again one force, which is just 40, so 40 over here. Now I can see that there are two equations with us. We can solve the two equations. How? We can divide the left hand side equation in the by the x cos theta one. So we can write x sin theta divided by x cos theta, which will be equal to 30 divided by 40, sorry. Now we will simplify it. It will be x will cancel out with x, 0 will cancel out with 0. Sin theta over cos theta is basically tan theta. So tan theta will be equal to 3 by 4. Now we can find out the value of theta from here. Shift tan inverse 3 by 4, which is 36.9 degrees. Similar, now for finding out, to find the value of x, we can substitute it in any of the above equation, either the left or the right. That doesn't make any difference. So let's substitute in this one, the right one. X will be equal to 40 divided by cos 36.9. so 40 divided by cos 36.9. Remember, the calculator should be in degree mode, because after your paper 1 it has to be in this. For mechanics basically it has to be in the degree mode. So the answer is 50 Newton. It is the force, so it has to be in Newton. Let's move to question number 2. Question number 2 says that a cyclist is traveling along a straight horizontal road. So there is a horizontal road, and on the horizontal road there is a cyclist who is traveling, and he is traveling with the speed of 4 meters per second when he passes a point O. So for example, if this is the point O, the speed at this specific place when he passes is 4 meters per second. She accelerates at a constant rate for a distance of 42 meters. Now she is accelerating and she has covered a distance of 42 meters. So now she has reached over here. When she has reached at this specific point, the speed over here is v meter per second. Now she maintains the speed of v meter per second for another 50 meters. So she travels another 50 meters with a speed of v meter per second. The speed has to be v over here as well. Now he says that, and then decelerate for 2 meter per second square before coming to rest. Now she is traveling further again, and remember, she is traveling when the distance traveled while decelerating is 16 meters. So this distance when she is decelerating is this distance is 16 meter, and the deceleration at that specific the final speed over here is going to be 0 meter per second because he's coming to rest, and the acceleration for this portion is going to be 2. Similarly, when the speed is constant throughout the journey of 50 meter, the acceleration value is going to be 0 meter per second square. We need to find the value of v. So let's jot down all of these things. If you could see the last portion, the distance traveled in the last portion is 16 meters. The acceleration for the last portion is 2 meter per second square, and the final velocity when he is reaching the destination is 0, and the initial velocity when he is starting, we are not aware of that. I'm talking about this part of the journey. So final speed is 0. The start speed for this journey is this portion of the journey is v. So let me write it v over here. Now we need to basically we are supposed to find the value of v. So we can use v square minus u square equals to 2as. We need to find the value of v. So v square minus the value of we need to find the value of u. So final speed is 0 square minus v square. 2 times acceleration is 2, and the distance covered with the acceleration is 16. Since the object is decelerating, so in place of acceleration you are going to put a negative sign as well, because it's not positive, it is not increasing acceleration, it is a deceleration. So it will be minus v square equal to 2 times 16 minus 64. Minus and minus cancels, and the speed the value of v is going to be 8 meter per second. Okay, now the b part says find the total time for which she is in motion from the instant that she passes O. So basically, if you see over here the sketch that I have tried to make over here, there are basically 3 portions of the journey. So we need to find out the total time for which she is in motion. Okay, so let's find out the total time for which she is in motion. Let's see. Let's start it from the right there in the middle. I'll call this as T2. The time that is being taken for this part of the journey. The speed, since the acceleration is 0, we cannot use any of the above formula. We'll directly use speed is equals to distance over time. So time 2 will be equal to 50 divided by 8. 50 divided by 8 is 6.25 seconds. Now this is the time that he has taken for the mid portion of the journey. Now let's calculate. Let's see. Let me call this as time 1. This portion of the journey where the initial speed is 4 and the final speed is v, which is 8, and the distance that he has covered is 42 meter. But we are in this portion, the first portion of the journey, the object is accelerating. So let's first of all find its acceleration using v square minus u square equals 2as. The final speed over here when he is reaching at this point, it is 8. So it's v8 square minus the starting speed when he is passing from O is 4 square. 2 times, we are unaware of the acceleration, the distance that he has covered is 42. So 64 minus 16 is 48 equals 2 times 42, which is 84a. So 48 divided by 84, the answer is 4 by 7. The acceleration is 4 by 7 meter per second square. This is the acceleration for first portion of the journey. Now using this acceleration, let's find out the time that he has taken to cover the first part of the journey, which is 42 meter long. So we will use the formula S is equal to ut plus half at square. The distance that he has covered is basically 42. The speed of the start is 4. We need to calculate the time plus 1 by 2. The acceleration for the first portion of the journey is 4 over 7. We need to calculate the time. Now if we simplify, we will have 42 equals 4t plus 2 over 7t square. If I make it a quadratic equation, it will be, let me write it here. It will be 2 divided by 7t square plus 4t minus 42 equal to 0. Let me use the calculator directly for finding this out. 2 divided by 7, 4 and minus 42. Okay, the value for t will be 7 and the other value for t will be minus 21. And since the time cannot be negative, so we will just ignore this value. This is basically time number 1, the time that he has taken to cover the initial portion of the journey. Now we need to calculate the time for the final portion, which is the last portion of 16 meters. So for finding that out, let's this is time decelerating. Okay, so let's calculate that. So we will use v is equal to u plus at. The final speed for that portion of the journey is 0 because he is coming to rest. The initial portion of the initial speed of that portion is v, which is, we calculated that as 8 plus the it's not accelerating, it is decelerating. So and it is decelerating with 2, so minus 2, and we need to calculate the time. So minus 8 is equals to minus 2t, cancels. So t3, the third portion time, time for the third portion is 4 seconds. So we need to calculate the total time. So total time will be t1 plus t2 plus t3. T1 is 7, T2 is 6.25, T3 is 4. Let's add them. 7 plus 6.25 plus 4. The answer is 17.25 seconds. This is the final answer. Okay, let's move to the next question. Question number 3. Question number 3 says that there is an aeroplane is flying at a constant speed. Okay, the aeroplane is flying horizontally. Okay, the aeroplane engines are producing a constant power of 5200 kilowatt. So power is basically 55,100,000 watt. The aeroplane experiences a horizontal resistance of 25,000. So resistance is basically 25,000 Newton. Find the speed of the aeroplane. So we need to find, since the object is in motion, so we will apply forward minus backward is equal to ma. The forward force is basically the driving force, minus the backward force is basically the resistive force, and mass we already do we have the mass? We don't have the mass. The acceleration will be 0. Why? Because he said that in the start that it is moving with the constant speed, so acceleration will be 0. So driving force, I'm sure you must remember a formula that power is equals to force multiplied by velocity. So force is basically the driving force. So driving force will always be equal to power divided by speed. So power we already have it. So power is how much? Yes, 55,100,000 divided by speed that we are interested in calculating. So V minus the resistive force is 25,000 equals to 0. So simplification only, 55,100,000 is equals to 25,000 V, and the value of V will be 55,100,000 divided by 25,000. The value of V will be 220 meter per second. Okay, let's move to the next part, the B part. The aeroplane then ascends 300 meters in 50 seconds. So with the maintaining the same speed. The same speed means that the speed that he was moving earlier, which was 220 meter per second, the resistive force is no longer constant since it's moving. Since it is ascending, so it is going to look like this. The plane is ascending. And how much distance is he covering? 300 meters. And in how much time? He is covering in 50 seconds. Okay. Okay, the work done against the resistance force in ascending the 300 meter. So there is a resistive force, the which is 270,000 kilojoules. What you need to do is find the mass of the aeroplane. The mass of the aeroplane is 60,000. You need to find the average power of the aeroplane engine. So since it's the change in energies that is happening, so what we will do, we will write down the energies before and we will write down the energies that are after. So there are three energies: potential energy, kinetic energy, and the work done by driving force. Okay, that they all comes in the before part. In the before part, the potential energy will be 0, and so will be the kinetic energy in the start, and the work done by the driving force, we need to calculate that. Let's mark it as X. In the after journey, let's write down the potential energy. The object is ascending 300 meters up. So mgh, we will apply mgh. The mass is 60,000. Yes, 60,000. The value of g is 10 and the height that he is covering is 300. So 60,000 times 10 times 30. It's 1, 2, 3, 4, 5, 6, 7. It's 18 and 1, 2, 3, 4, 5, 6 and 7 joules. Okay, the kinetic energy will be 0 in the after part as well. Why? Because the speed is not changing. The speed that was earlier, that speed is the same now. And what else do we have? We have the work done against friction. Against. So how much work done has been done against friction? 270,000 kilojoules. So it's going to be 270,000 joules. Now we know that the law of conservation of energy. So the energy before and the energy after, they are both going to be equal to each other. So the energies before will be 0 plus 0 plus x. So let me write it x directly, which will be equal to the energies afterwards, which is 18 with 7 zeros, 1 2 3 4 5 6 and 7, and similarly 270,000. So the value of x, what is basically x? X is the work done against friction, and the work done against friction, so 270, 1 2 3 1 2 3, it's basically it's 45 with 7 zeros. Okay, now since we were interested in finding the average power of the plane, so power is equals to energy divided by time, and work done is also a form of energy. So work done is 4 5 1 2 3 4 5 6 7 divided by, he is covering it in 50 seconds, so divided by 50. So divided by 50, it's 1 2 3 4 5 6 1 2 3 6. So it's 900,000, no, 9,000 3 and 6 joules. Okay, since, oh no, it was not joule, it's watt. We found power. Let's move to question number 4. Question number 4 says that two particles A and B have mass 0.3 kg and 0.1 kg respectively. The particles are attached to the ends of a light inextensible string. The string passes over a fixed smooth pulley, and the particle hangs vertically below the pulley. Both particles are initially at a height of x meters from the horizontal ground. Okay, the system is at rest. So basically both the particles are initially at rest, which means that the speed of both the particles in the start is 0. So let's first of all find out the direction of the tension in the string. The tension is upwards and upwards, always towards the pulley. We need to find the tension in the string and the acceleration of the particles. So let's try to simplify for both of them separately, but let's start it from A. For A, so there will be a downward force as well, that will be in the form of a weight. Weight will be equal to 0.3 times 10, which is 3, and the weight over here as well will be 1 Newton. So upward force is equals to downward force, because not upward, this is a movement question. So forward minus backward, the forward is the result, the object is moving, na? So it will be forward minus backward is equals to ma. So the forward force for A is going to be the forward force for A, since the object weight is more, so it's going to bring it down. So it's going to be, because no external force is being applied, so 3 minus T is forward minus backward is equals to ma, which is 0.3 times A. And similarly for B, For B, since the object will move upwards in the direction upwards, so tension will be more than the weight, so 1 minus T minus 1 will be equals to 0.1 times A. Now we will simplify that such that we will make one of them the subject, so T is equals to 0.1 A plus 1. We have the value for T. Let's substitute it in any of the let's substitute it into the other equation. So 3 minus bracket 0.1 A plus 1 is equals to 0.3 A. If we expand it, it will be 0.1 A minus 1 is equals to 0.3 A. So it will be 2 is equal to 0.4 A. So the value of A will be 5 meter per second square. We can find the tension by substituting this value of A in the other equation. So 0.1 times 5 plus 1. So it will be 0.5 plus 1. So the tension will be 1.5 since it's the force, so it's Newton. Let's move ahead. The next part is during the subsequent motion B does not reach the pulley. When A reaches the ground, it comes to rest. So what is happening? It is happening that this A object is going to go down and it is going to hit the ground over here like this. But the object B is not going to touch the pulley, but for example it is going to come right here. Okay, and it is the B object is also going to stop when the other object A is going to reach the floor, the ground. Given that the greatest height of B above the ground is 1.2 meters, find the value of X. So the what does he mean is that the total height of B can be 1.2 meters. This complete height is going to be 1.2 meters. Okay, now but how much distance is he going to travel? Let's see. Given the greatest height of B above the, find the value of X. So we need to figure the value of X. X is the distance that the object A and B are at the start. So let's start with A first. Let's talk about A. And for A, we know that object A is initially at rest. It is at 0, and the object A is going to reach some speed when it is about to hit the floor. We are not aware of that, but the distance that the object A is traveling, it is X, and the acceleration by which the object A is traveling is 5. So let's figure out the unknown speed over here, because the speed with whichever the object A is traveling, it will be the same speed as which the object B is going to travel. So let's substitute V square equals to minus 0 square equals to 2A and S. So it will be V square equals to 10A, and instead of S we are basically, instead of S we will write down X, and acceleration is basically 5. So it will be 10x. Now let's see, the object B is traveling with the same speed as the object A because both of them are connected. So we know that the initial speed of the object B, the initial speed of the object B will be the same as the final speed for that. It will be 10x, and the final speed of the object will be 0. and the distance that the object is covering, the distance is, this is object B, it is going to travel this much distance, and this is going to be the same distance as object A has traveled to reach the ground, and that is x. So this, since object A is traveling x meter down, so object B is also going to travel x meters up. So the distance is going to be, total distance is going to be 1.2 minus x, because it was already x meters above the ground. So 1.2 minus 2x will be the distance, and the acceleration by which it is going up, it is going to be 10 minus 10 meter per second square. Now we know that v square minus u square is equal to 2as. The value of v is 0, so 0 square minus u square is 10x, 2 times acceleration is minus 10, and the distance that he is covering is 1.2 minus 2x. So it will be minus 10x equals minus 20 bracket 1.2 minus 2x, minus will simplify, so 10x will be equal to 20 times 1.2, which is 24, minus 20 times 2, which is 40x. So if I simplify, if I take it to the other side, it will be 50x equals to 24. The value of x will be 24 divided by 50, which is 12 by 25. The value of x will be 12 by 25, or 0.48 meters. This is the height that the objects are above the ground, the A and B both. Let's move to question number 5. Question number 5, then 6. Okay, let's do question number 5. Question 5 says that there is a particle P, there are 3 particles P, Q and R of masses 0.6 kg, 0.4 kg and 0.8 kg respectively are at rest in a straight line. Okay, so all of them are at rest on a horizontal smooth plane. So initially all of them are at rest. The distance from P to Q is 3 meters and the distance from Q to R is 3 meters as it is shown in the diagram. P is projected directly towards Q with a speed of 3 meters per second. So initially the speed of the object P is 3 meters per second. So the speed for P will be 3 meters per second. After P and Q collides, P continues to move in the same direction with the same speed. When the P object reaches over here and collides with this, the speed of the P's object becomes 1.5 meter per second. Okay, and it is going to move in the same direction it was moving earlier. This is the direction that it is moving. Find the speed of Q after collision. So it's a very simple question. It's about momentum. So we are aware that momentum before collision will be equal to the momentum after collision. So momentum before collision will be equal to the momentum after collision. So m1 u1 plus m2 u2 will be equals to m1 v1 plus m2 v2. We need to find out v2, that is the speed of the object Q after collision. So m1 is the mass of 0.6 multiply by the initial speed of the object P is 3. plus the object q is already at rest. So if you multiply the mass with 0, it is ultimately 0. The speed with which the object p moves after collision, it is 1.5, so 0.6 into 1.5. The mass of the object q is 0.4 and the speed after collision is unknown. So it's 0.18 minus 0.6 into 1.5. It's minus 0.9 equals 0.4 v2. So it will be 0.9 equals 0.4 v2. So 0.9 divided by 0.4, it will be the speed with which the object q will move after collision, the 2.25 meter per second. In the subsequent collision between q and r, these particles coalesces, which means that they stick together. Okay, you need to find out the speed of the combined particles after collision, the same thing. So momentum before collision is equal to momentum after. So momentum before will be between q and r now. So mass is 0.4, and now after this is the scenario between q and r, and after the collision between p and q. So the initial speed of the particle q is going to be the 2.25. that was the final speed before the speed after collision for the previous scenario, plus the object r is at rest because it is not hit by the object yet, and it will be equal to the momentum after. So after hitting together, they are joined, they are combined together, they are sticking together. So the mass is going to be 0.4 plus 0.8, and they are moving with the speed together now. So let me mark it as v. So it will be 0.4 into 2.25, which is 0.9 plus 0. It will be equal to 0.4 plus 0.8, 1.2 v. So the v will be 0.9 divided by 1.2. It's 0.75 meter per second. This is the speed with which they are going to move together after combining. Okay, the next is part C. The part C says that find the time taken that it takes for P from when P is initially projected until the instant at which P collides with the combined particle. Okay, so we need to find out the total time from the start when P is being projected, P is starting the movement. So let's calculate that time. Let's calculate the time taken by P to Q, and that is going to be, let me mark it as T. So T from this, since it is the time, the speed at that portion is 3, and the time is going to be from P to Q, object P is traveling with the same speed. 1.5 meter per second is the speed after it had a collision with Q. So throughout P to Q, it had the same speed, which is 3 meter per second. So time is equals to 3 divided by, that is also 3. So it took 1 second for the object to reach from P to Q. Now let's calculate the time taken by Q to R. Now after the collision, the particle Q is going to travel in the same direction, and how much time it is going to take, let me mark it as T2. It will be how much distance is he traveling, 3 with the speed of 2.25 meter per second. So 3 divided by 2.25, which is 4/3 seconds. Now what is happening? Look over here. Now let's calculate the distance that is covered by P to QR. Distance after P being hit, after the Q has moved the distance in from the object Q has traveled from Q to R in 4/3 seconds. So in this 4/3 seconds, the particle P is obviously also traveling in the same direction. So how much distance is he covering? I hope that makes sense to you. So object P after collision is moving with the speed of 1.5 meter per second, and the time, that is 4/3. That is the same time when the object Q has traveled to R completely. So it will be 1.5. This is 2 meters. So basically what is happening, let me show you a visual diagram. This is object P. It is traveling and it is reaching the particle Q. Then there is a collision, and then they go to the particle towards the particle R. Now the time taken from P to Q is 1 second. The time that has taken for Q to reach R is 4/3 seconds. This is the time that Q has taken to reach the particle R. In the meantime, P was also traveling, and P has traveled a total distance of 2 meters. This is I repeat it again, that this is the distance that is covered by the particle P when particle Q has reached over here. So still there is 1 meter more distance left by the particle P to cover. I hope that makes sense. Now distance between, let me write down the distance between P and QR. Now the object P has reached over here. Now how much distance is it? 1 meter. Okay. Now let's find out the relative speed. How much is the relative speed, so that we can find the time as well. So the relative speed will be 1.5, which is the speed with which it is moving, minus the speed that is after the speed of the particle after collision, that is 0.75. So this is 0.75 meter per second. Now we know the distance. Distance is equals this. So we need to find out the time. Time will be 1 divided by, because that distance is P till QR is 1 meter. So 1 divided by 0.75, the relative speed. So 1 divided by 0.75 will be 4/3 seconds again. So total time, we need to calculate the total time. Total time will be 1, which is the portion first. Then the time 4/3 seconds when he has covered 2 meter distance. And then there is another 4/3, which is let's calculate 4/3 plus 1, 11 by 3 seconds. 11 by 3 seconds. Now let's move to question number 6. Now question number 6 says a block of mass 12 kg is placed on a rough plane inclined at an angle theta alpha to the horizontal, where alpha is equals to tan inverse of 0.5. So let me write down tan inverse of 0.5 means tan alpha will be equals to 1 by 2. So if I make a diagram over here for a right angle triangle, and if this is theta and 90 degree, so this side will be 1 and this side will be 2. I can calculate the hypotenuse with the Pythagoras theorem, which will be square root 5. Now by these values I can easily figure out the value for sine alpha, which will be 1 by square root of 5, and similarly the cos alpha, which will be 2 by square root of 5. Now he says that a force of x Newton is applied to the block directly up the plane. The coefficient of friction between the block and the plane is mu. It is given that mu is 0.15 and x is 20 Newton. Find the time that it takes for the block to move 2 meters down the plane from rest. Okay, so basically what is happening, find the time it takes for the block to move 2 meters down the plane from rest. Okay, so the object is going to move down the plane. So let me mark the direction. This is the direction that object is going to move. Since it is, we need to resolve the forces, the mass as well, which will be 120. So if I resolve it, the vertical and the horizontal, this will be alpha. So this component is going to be 120 cos alpha. This will be 120 sin alpha. Okay, since the object is moving and it is covering a distance of 12 meter, so we will apply forward minus backward is equal to ma, and by using it we will find out the acceleration first. Forward force is just 1, which is 120 sin alpha, and the backward force is since the object is in is having a resistance, so the object is moving downwards, the resistance is going to be backward, which will be mu r, minus the backward force is also x, which will be equal to ma, which is 12 times a. We can calculate the value of r. R will be in the upward direction to the plane. This is r, and r can be calculated by putting the upwards and the downward forces equal. So r will be 120 cos alpha. So cos alpha value is known to us, which is 2 divided by square root of 5. So it will be 240 divided by square root of 5. This is the value for r. Now let's substitute the values over here. Sin alpha is also known, which is 1 by square root of 5. So it will be 120 by square root of 5 minus the value of mu is 0.15. The value of r is 240 over square root of 5. The value of x is 20 and m, which is 12a. So 0.15 into 240, which is 36. So 120 minus 36 over square root of 5 minus 20 is equals to 12a. Let's simplify. 120 minus 36 is 84. 84 divided by square root of 5 minus 20. The value is 17.56594, which is equal to 12a. So divided by 12, it will be, the acceleration will be 1.46382 meter per second square. Now we need to find out the time, so we will use S is equal to ut plus half at square. Since the object was at rest initially, so the initial speed is 0. The speed that he is covering is 2, the distance that he is covering is 2 meters. So plus 1 by 2 into 1.4638 into t square, multiply by 0.5. So it will be 2 equals 0.7319 t square. So 2 divided by this will be t square, which will be 2.7325, and the value of time will be 1.65 seconds. Okay, now let's move to the next part. It is given that that mu is not 0.15 now, and that when x is 10 Newton, the block is on the point of moving down the plane. Okay, it is about to move down the plane, it is not moving, so you cannot apply forward minus backwards. So when it's about to move, so you apply the equilibrium conditions over here. So find the value of mu and the value of x. Find the value of mu and the value of x for which the block is on the point of moving up the plane. Okay, so there are two scenarios over here. Let's do them both. So up will be equal to down, and right will be equal to left. So r will be r is not going to change, r will be the same, and value of r will be 120 cos alpha. Cos alpha was square root of 2 by square root of 5, so which was 240 divided by square root of 5. This is the value of r. We are doing the case move down. So right is equals to left, so about to move down. So move down means that the right force and the frictional force, both of them is going to be in the same direction. So x, which is 10 plus mu r, and the left force will be 120 sine alpha, the same. 120 sine alpha is 1 by square root of 5. The value of r we just found out. We need to calculate the mu, 240 by square root of 5. So 120 by square root of 5 minus 10. It will be 43.6656, which will be equal to 240 over 5 mu. So this divided by 240 over square root of 5, which is going to give the value of mu as 0.41. Now let's 0.406. So let's write down 407. Let's write down 407. Okay, now we need to do the case 2. Case 2 is that when it is going to move up the plane will only make one difference, that the friction is going to go in the opposite direction. So the rest of the things are going to stay the same. So the right and the left. So the right force is going to be only 1, which is x, and the left force is going to be 120 times sine alpha, which is 1 over square root of 5, plus there will be friction. The friction is going to be the same as the friction will be mu r. The value of mu will be the same because this is the same case that he is talking about, 0.407. The value of r is 240 over square root of 5. So if I simplify, it will be 120 over square root of 5. So 240 into 2.407 divided by square root of 5. If I add this is basically 43.6838. If I add 120 by square root of 5, it will be the value of x, which will be 216 divided by square root of 5, or you can write it as 96.6 Newton. Okay, let's move to the next question, question number 7, and that's the last question for this paper. Question number 7 says the particle moves in a straight line. The velocity v meter per second of the particle t after leaving a fixed point O is given by this formula. Okay. Where k and p are constant, the acceleration of the particle at t equals to 1 is 42 meter per second square. So he says that when the acceleration is 42 when the time is 1. And he says that the displacement of the particle from O means the start, till the time 1 second, it is 93. So in 1 second, the particle has covered a displacement of 93 meters. Show that the value of k is 3 and the value of p is 26. Okay, so it's very simple that v is k. Let me do the expansion first. 20k minus pk plus pkt minus kt square. This is the expression that we have. And we know that if I do the differentiation of the velocity time equation, I'll have the acceleration. So dv by dt, this will be 0, this will be pt minus 12 kt, and we are very well aware that this portion is basically this is the acceleration. And we are aware that the acceleration is 42 when the time is 1 second. So let's put the value of 12 p plus minus 12 times k. When the time, in place of time t, I have placed 1, and in place of acceleration I have placed 12. I can it's p, and there is a k, there is a k as well. So kp minus 12k. So if I take k as a common, so it will be 12 divided by p minus 12. Sorry, k will be equals to this is 42, so 42 divided by p minus 12. Okay, now the next there is another portion of the question which says about the displacement, and we know that if we do the integration of the velocity time graph, we find out the displacement. So if I talk about displacement, it will be s will be equal to, and the displacement that he is talking about taking as 93, it is for the first 1 second. So the limits that we will put will be 0 to 1, and the equation will be 20k plus pkt minus 6kt square dt. Now if I do the we are aware that the displacement is 93, so displacement will be placed at 93, so it will be 20 kt plus pkt square divided by t square divided by 2 minus 6 kt cube divided by 3, and the limits will be 0 to 1. So if I put 1, the upper limit, it will become 20k minus pk divided by 2, and minus this will be 2k minus the lower limit. If I put 0 in all of these equation, it is going to ultimately give me a 0. So this is the upper limit minus the lower limit will all automatically be 0, equal to 93. So for what can I say is that I have a k common over here. Let's take this k common. It will become 20 minus p by 2 minus 2 equals 93. Now k will be equal to k 2018, so it will be 93 divided by 18 minus p by 2, and the values of k, both of them will be equal to each other, so let's put them both equal. 42 divided by p minus 12 will be equal to 93 divided by 18 minus p by 2. Cross multiply them. 42 times 18 is 756, so and 42 divided by 2 21. It will be, this was a plus, this was a plus, so plus it will be 21p equals 93 multiplied by 7, so 93p minus 93 times 12, which is 1116. Collect the like terms. 21 minus 93 is minus 72p, minus 116 minus 756 minus 1872. Simplify them both, so the value of p will be 26, and I think this is what he was saying that in the question. Yes, now let's calculate the value of k. The value of k is 42 divided by 26 minus 12, so k will be 42 divided by 26 minus 12, which is 3, and that is what he was asking us to show. Yes, let's move to the last part of the paper. The last part says that find the distance moved by the particle between the time at which the acceleration is 0 and the time at which the velocity is 0. So we need to find out the distance that the object has covered during these two situations. So let's take these two scenarios. When time acceleration is 0 and the other is when the velocity is 0. We know that the acceleration is 0. We already have found an expression for that, and the expression is this. This is the expression for acceleration. So it will be, and the acceleration is 0, so 0 will be equal to, we already have the value of k. The value of k is 3 and the value of p is 26, so it will be 3 times 26 and . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, so this is 3 times 26 minus 12 times 3 times t. So 3 times 26, 78, minus 78 equals 12 times 3 is 36. So the time is going to be 78 divided by 36, which is 13 by 6 seconds. So this is the time when the acceleration will be 0. Similarly, we have an expression for the velocity as well, which was given to us at the start, which is this, and he says that velocity is 0. Let me just substitute and let me identify what was the time at that specific point. So 0 equals 2 times 3, 20 times 3, because k is 3, 26 times 3 times t plus minus 6 times 3 times t square. So 60 plus 26 times 3 is 78 t minus 18 t square and equal to 0. I'll simplify, I'll get the values of t. The values of t will be minus 18, 78 and 60. Okay, the one value of t is 5 and the other value of t is minus 2 by 3. Time cannot be negative, so we will ignore it. So these are the two times when both of them are having the one time is when the acceleration is 0, and the other time is when the velocity is 0. So we need to find out the distance that they have covered. We have already found an expression for the distance, which is 20k. Okay, let me write down the expression. It's 20, it's the integration, and the lower limit is going to be 13 by 6 is 3.1. So it will be 13 by 6 here and 5 here. It's 20k. Let me write down from here directly. It is 60 plus 78 t minus 18 t square and dt. So if I do the integration, it will be 60t plus 78 t square divided by 2 minus 18t power 3 divided by 3, and the limits are from 5 till 13 by 6. So if I substitute 5 first, so 60 times 5 plus 78 by 2 is 39. So 39 bracket 5 square minus 6 bracket 5 cube. This was the upper limit, minus the lower limit will be 60 into 13 by 6 plus 39 into 13 by 6 square minus, this is 6, minus 6 bracket 13 by 6 whole power 3. This will be the lower limit. Let me squeeze it a bit. Okay, now I'll simplify. It will be 60 into 5 plus 39 into 125 minus 6 into 125. Sorry, this is 25, not. This is 525 minus the lower limit is 60 divided by 6 times 13, 130 plus 39 into 13 by 6 uh, so it will be 1 minus 130, 13 by 6 square multiplied by 39. This is 2197 divided by 12 minus 13 by 6 power 3 multiplied by 6, 2197 divided by 36. So 130 plus 2197 by 12 minus 2197 by 36, that is, so it is 525 minus 252.055. So if I subtract 525 minus this, the answer is 4913 divided by 18 meters, or 272.9 meters. This is the distance that is being traveled between the two durations. Okay, that was the end of this paper. I hope you understood all the questions. If there is any query regarding this paper, please leave it in the comment section. And I hope you like the video, please do share it with your friends as well. And if there is any specific area or topic or paper that I have not covered yet and you want me to cover, please leave it also in the comment section. Thank you for your support. Thank you. Allah Hafiz.